When we're finding the shortest distance from a point to a line, what we need to do is we need to recognize that we're going to have to go from here to somewhere over here. But when we're doing this, there should be some things that we need to realize. First, we have to do it at a right angle. Because if we do it at anything other than a right angle, we're actually creating a hypotenuse, which is always going to be longer than that right angle. Next, when we're finding a right angle, well, that's going to tell us that we have to use the negative reciprocal slope. So if I've got this line, which that's something that we're given, to find that right angle, if I know the slope of the line, I can then find the slope of the line that I'm traveling along here. If I can find that slope, and I can actually then find the equation of the line, I can find the point of intersection. And once I find the point of intersection, I can find the distance between where I'm at and that point of intersection to find the shortest distance. So if we were walking through an example here, we've got how far are you from the road if you're at point -1 and 3 and the road is x plus y minus 5. Well, the first step is we need to go through and we need to rearrange this into y equals mx plus b, which is going to be -x plus 5. We're just moving the x and the 5 to the other side. And then we can see that our slope here is -1, or -1 over 1. Now, if I want to find the perpendicular slope, what I need to do is flip the fraction, -1 over 1 stays 1 over 1, and make it positive. Well, we now have -1 becoming 1. Our next step is we're going to use our point. We have x and y. And we're going to sub into y equals mx plus b. After we have that, we're almost done. Okay, so we're subbing in here. We're going to get 3 equals 1 times -1 plus b. That's going to be 3 equals -1 plus b, and b is equal to 4. From that, I've got my slope. I've got my b value. I can then write, therefore, we've got y equals x plus 4. There's my equation. Well, I've got my two equations. I can sub my values in here because I need to find my point of intersection. So I'm going to get then x plus 4 minus 5 equals 0. Well, that's going to be 2x plus 4 minus 5, which is -1, equals 0. And then I'm going to get 2x equals 1, and x is equal to 1/2. Well, if x equals 1/2, I can sub that in to this equation here and find out what my y is. That's going to be 1/2 plus 4, which is going to be 1/2 plus 8 over 1/2, which is 9 over 2. I could also write these as 0.5 and 4.5 because they're not too hard of decimals. So therefore my point of intersection is going to be 1/2 and 9 over 2, or 0.5 and 4.5, which I'm going to use the decimals in this case because they actually work kind of nice. And now I've got my 2 points. So I've got point, and we'll call the other one A, is 1/2 and 4.5. And all I'm going to do is find the distance of that line because that's going to give me the distance to the road. So what I'm going to do is I'm going to have the length of AP is going to be equal to the square root. And remember, we need to find the distance between those, the average value. So we're going to have -1 minus 0.5 squared. And then I'm going to have plus 3 minus 4.5 squared. I'm going to get my values. So I'm going to get 1.5, so the square root of 1.5, because it's absolute values. -1 minus 0.5 is 0.5. So I'm going to have 1.5 squared plus 1.5 squared. So I'm going to get 1.5 squared plus 1.5 squared is going to be the square root of 4.5, because 1.5 squared is 2.25. And then after that, I'm going to end up square rooting my value to get an approximate answer of 2.1. So we could either say 4.5 or square rooted, or 2.1 is going to be the distance from you to the road.